Hello viewers, welcome again to this lesson. In our previous lesson we talked about the trapezium rule, and we also explained briefly counting rule as a method of estimating area, which was learned way back in Form 1. We also gave some examples on how to determine the trapezium rule. Today we want to look at how to be able to determine or estimate or approximate the area under a curve using the mid-ordinate rule. Now, assuming we are asked to estimate the area under the curve from x equals to 0, to x equals 6. Assuming we are asked to calculate the area under the curve A, x equal to 0, x equal to 6, and the x-axis, meaning it is this area here. So we have this area under this curve here. That's what we want to estimate using the mid-ordinate rule. Now we know that the way we get h is always the same, whether in trapezium rule or mid-ordinate rule, where h equals to b minus a over h, and in this case h will be 6 minus 0 over 6, because the number of n is the number of ordinates, mid-ordinates. So this is h equals to 1. So our h is 1. If our h is 1, it means that we have one ordinate is here, another one 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 is here. But the question is, we have to use the mid-ordinate rule. So if this is one ordinate, this another 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 one. The mid of this ordinate is here, maybe 0.5 there. So if I draw a dotted line to indicate the ordinate to the curve, that's where we have this, the trapezium. Let me just join it to the curve. I don't have to reach there. What we need to do is to develop something like a rectangle, just from the point where the mid-ordinate touches the curve. We draw the horizontal line there to be able to get what we refer to as the ordinate. So this is one ordinate. It's actually a rectangle, but this is the mid-ordinate. So we need to get the value of x here. Remember, the value of x here is 0.5. This is 0.5. So if you have the first ordinate as mid-ordinate is the first 0.5, the next mid-ordinate will be 0.5 plus h. So 0.5 plus h here, and h is 1, 0.5 plus 1 will be 1.5, the center of the second ordinate here. So the second ordinate, if we draw it here with a dotted line, so in my diagram here, the dotted line will represent the mid-ordinates, while the continuous lines will represent the boundaries of those ordinates. So this is what we have for the second ordinate. That is what we have. Now again, if this is the second mid-ordinate, which is 1.5, the third mid-ordinate will be 1.5 plus h, which is going to be 2.5 here. So again, if you draw that mid-ordinate, I draw a dotted line. Remember, the dotted line must come from the curve exactly. It is what is guiding everything for this particular ordinate here. So when I have it like that, I will draw a horizontal line on that, exactly at that point, and then I extend this line here to that particular point. Then again, the next mid-ordinate will be 2.5 plus 1, or the center of 3 and 4 will be 3.5. Then again I draw a dotted line indicating the mid-ordinate. The dotted line, I said, must come from the curve, and it is on that we draw the mid-ordinate, or we draw the ordinate which is there. and then this one will go this way. Then we go for the next one. Again, from 3.5 to here we'll get 4.5, which is the next mid-ordinate. We draw a line there, and that line is the mid-ordinate. Let's extend this because we need to draw a rectangle moving this way. Then this line is continuous, coming from up there. We draw this like that. Then finally we have 5.5, the last mid-ordinate. So the last mid-ordinate is 5.5. We use a dotted line to draw it. So I'm going to draw it up to there. And then we can draw the rectangle coming from there. So viewers, you can see how I'm developing these things. We know this line must be continuous because if you leave it as dotted, it may confuse us. So this must be continuous like that. So I've drawn here up to 1, 2, 3, 4, 5, 6 ordinates. The mid-ordinates are at this particular point. Remember, in examination, these mid-ordinates are the most important ones because they're the ones you need to fill in the curve to be able to determine the values we are going to use. Now, after we reach this particular point, we know that we just need the y's. This is y 1, 2, 3, 4, 5, 6. So let's say y1, y2, y3, y4, y5, y6. Remember that in this case I'm trying to avoid using y0. Why? Because if I use y0, I'm going to have y5, but the ordinates are supposed to be 6 in total, so that will kind of bring some kind of confusion. So here I'm just using y1 for each mid-ordinate. Remember, I'm not starting on the boundaries here. If I have start from the boundaries here, that means we are using a concept related to what we call the trapezium rule. So once we have this particular case here, we know that the distance here, the height of each ordinate is h. That is what we have there. The height of each ordinate is h, and they are uniform for all the ordinates. And remember that the ordinate here, this length here, is also the same as the length of this particular rectangle. Remember, these are rectangles. Rectangle A, rectangle B, rectangle C, D, E, and finally rectangle F. So those are rectangles. So if this is the center of a rectangle, if you have a rectangle this way, the center here, the length of this center is the same as the length of this other side. So we can say that we have length times width. So the length here is y1, the width is height here, because this is the center. Any length, any parallel line on a rectangle will always be equal to the other opposite sides. So this length y1 is, this one is also y1. The other length for this rectangle is also y1. So we can say that the area, if you have areas of area of a rectangle is length times width. And we know that if I start by saying if this is the area, length times width for A, it is y1 or h times y1. H y1, let me just write h y1 for A. For B, it is h y2. For C, it is h y3. For D, it is h y4. For E, it is h y5. For F, it is h y6. Those are the areas of each particular ordinate. So when you are going to look for the total area here for this region here, estimated area should be the sum of all these rectangles, which is going to be h y1 plus h y2 plus h y3 plus h y4 plus h y5 plus h y6. Now we know that in this case h is very common all through, so we can say the area here will be h, factorize h, so that we have y1 plus y2 plus y3 plus y4 plus y5 plus y6. Now the area under the curve between x equals to 0 and x equals to 6 using the mid-ordinate rule can be given by this formula here. Now you realize that this formula simply translates to the sum of the mid-ordinates times the common height or the common width of each ordinate here, or each rectangle. You can see that we have only the value of the rectangle 1 height times the sum of the ordinates there. So that is simply what mid-ordinate rule translates to. Let us look at an example. So viewers, we have this question, and just like we dealt with the trapezium rule, we know that h is given by b minus a over n, where b is the biggest value of x minus the smallest value of x, that is 3 minus negative 3, divided by n. N is the number of ordinates, which is 6. So h here will be 6 over 6, which is 1 unit. Now we know that once we have that 1 unit, let us be able to draw a table. This table will be table of the mid-ordinates. The mid-ordinates y1 to y6, as because we have from 3 to that. So if you have 1, 1, 1, from negative 3 to 3, you will be having 6 ordinates. If you have x, y here, I'll say now these values of x must be at the mid-ordinates. Now if I take 1 unit from negative 3 to negative 2, that will be 1 ordinate, because we are dealing with 1 unit height or width. Now the midpoint of this point should be negative 2.5. So the mid-ordinate here we'll use is 2.5. Now I said that after to establish the first ordinate, then for you to now to move to the forward one, the next one, you will simply add 1 to each. So I'll add 1 to this, which will be negative 1.5. Then I add 1 here will be negative 0.5. I add 1, I will get 1 plus this is 0.5 plus 1, I will get 1.5 plus 1, I will get 2.5. Remember, these are the dotted lines I was drawing. These are what we call the mid-ordinates. So because those are the ordinates, the mid-ordinates will be able to help us to be able to determine the points or the ordinates where we need to be able to working with. So with this one, this is where y1 will be, y2, y3, y4, y5, and finally y6. So what I need to do here is to substitute this value of x, of the mid-ordinate, to the function, which is going to be 0.5 or a half times negative 2.5 squared plus 1. And that is going to be 4.125. Then I know that that one will be the same as the other value there. So let me just go 0.5 into negative 1.5 squared plus 1. That is 2.125. Then 0.5 into negative 0.5 squared plus 1. Get 1.125. And then 0.5 into 0.5 squared plus 1. Again 1.125. Then 0.5 into 1.5 squared plus 1, 2.125. And then 0.5 into 2.5 squared plus 1 is 4.125. So we have the mid-ordinates. The mid-ordinates we are able to work them out. So we have the formula now. The formula we said will be area is h into the ordinates is y1 plus y2 plus y3 plus y4 plus y5 plus y6. Then we substitute height is 1, times 4.125 plus 2.125 plus 1.125 plus 1.125 plus 2.125 plus 4.125. So if we add that, we'll get 4.125 plus 2.125 plus 1.125. Remember that 1, 2, 3, then it repeats itself, so I can add this, then I multiply by 2 times 2. That will be 14. I know the sum I multiply by 1 will be 14.75 square units. This will be the area under the curve. You remember that the same area, the same diagram, we are able to determine it using the trapezium rule. And with the trapezium rule, we got 15.5 square units. But with the trapezium rule, with the mid-ordinate rule, we are getting 14.75 square units. So that could be, we don't know until we are able to get what we call the exact area using integration in the next chapter. We can then determine between these two methods which one correctly or estimated the area more suitably. Okay, let's look at example 2, which reads, below is a sketch of a curve y equals to 3 minus 5x minus 2x squared, and this is the sketch that we have here. We are told to find the coordinates of points A and B, this point and this point here. You realize that earlier in the chapter of differentiation, we learned how to get the x-intercepts, and these are now the actual x-intercepts, because the x-intercept, we said, is at the point where the curve intersects or cuts the x-axis. So we need to get the x-intercepts here. Now at the x-intercept, we say the value of y is 0. At x-intercept, the value of y is 0. So we'll take 0, we substitute here on the curve. So I can say 0 equals to 3 minus 5x minus 2x squared. But now if I want to ensure that this is not negative, I'll bring in 2 the other side. So I'll say positive 2x squared plus 5x plus plus 3 minus 3, minus 3. If I happen to bring this on the other side, this is positive, this is negative, equals to 0. So we realize that here the product is 2 times negative 3, which is negative 6, and sum is plus 5. So probably the likely numbers we have here is positive 6, and negative 1. So that if you have negative 1 times positive 6, you get negative 6. 6 minus 1, you get plus 5. So we'll get 2x squared plus 6x minus x minus 3 equals to 0. This is, if I factorize here, group these two, you get 2 into 2x into x plus 3 minus 1 into x plus 3 equals to 0. So you say 2x minus 1 into x plus 3 equals to 0. So after we determine that, from here we can actually say that either 2x minus 1 equals to 0 or x plus 3 equals to 0. So here x is actually, take 1 here, divide by 2 is a half, or x is negative 3. So we can tell that because a is on the negative side of the curve, so we know that a here should be, we know the values of y should be 0. So coordinate a should be negative 3, 0, and coordinate b should be this one here, which is a half, 0. So we have the coordinates of the points of intersection of the curve and the x-axis, that is point A and point B. Now, down here we are told to estimate the area enclosed by the curve y equals to 3 minus 5x minus 2x squared. Now, enclosed by the curve y equals 3 minus 5x minus 2x squared, x equals to negative 3, x equals 0, and the x-axis using the mid-ordinate rule with 3 strips. So, meaning that from negative 3, we have seen that negative 3 is here, from here, and we can divide here into 2, so that we have negative 2, negative 1, 0 is here. So, meaning we want from these strips here, 3 strips from x equals to 3 to x equals 0, that's 1, 2, 3. So what we need to do, because we're using mid-ordinate rule, the mid-ordinates must be here for the strips. This is the mid-ordinate. Let me say this is the first strip, this is the other strip. So this is the mid-ordinate here. Let me now be able to sketch them. Another mid-ordinate will be here, which we can say now is going to go like that. Another mid-ordinate is here, which will be like that. So these are the strips that we have. So these strips here, we know that we have to get these values of y, which is y1, y2, y3. And for us to do that, we'll need to bring in the table. And the table here, if I draw the table, x and y, where these y's will correspond to the ordinates, the mid-ordinates. So there are 3 of them. So this is the first value of x that we need to use there is at this point, which is negative 2.5. This is negative 1.5. This is negative 0.5. So I'll take this negative 2.5, negative 1.5, negative 0.5. Those are the coordinates of the mid-ordinates that we need to use to get the values of y. So we'll take these values, we substitute in the function 3 minus 5 into negative 2.5 minus 2 into negative 2.5 squared. That is 3. So that is 3.0. What about if we substitute negative 1.5? We'll get 3 minus 5 into negative 1.5 squared minus 2 into negative 1.5. 1.5 squared? No, it's 1.5. Then minus 2 into negative 1.5. 1.5 squared. We get 6.0. And then we substitute negative 0.5, that is 3 minus 5 into negative 0.5 minus 2 into negative 0.5 squared. We get 5. We get 5, yes. So this is 5.0. So once we have those particular values, we can then be able to use our formula, which we said area, according to mid-ordinate rule, is h into y1 plus y2 plus y3 in our case here. And we know that how do we get h? We said h equals to b minus a over n. And h here will be, b is the bigger value, and the bigger value here is 0. So we'll get 0 minus the smaller value is negative 3. Minus negative 3 over n, and n here we have been told is 3 strips over 3. So 0 minus 3, 0 plus 3, which is 3 over 3 equals to 1. So the value of h there is 1. So we'll say here 1 times y1 is 3 plus y2 is 6 plus y3 is 5. So we'll say that is this is 5. 5 plus 8 plus that is 14. So we'll say that is 14 times 1 square units. So viewers, that is how we can calculate the area under that using the mid-ordinate rule. Let us know if you really understand the concept of the mid-ordinate rule or the trapezium rule. Thank you very much, and please try to subscribe to our channel so that you can support us in this particular